All right, we're on a new module, so module 1, topic 3. This is a small topic where we're primarily working with angles. Today we'll be working with inside and outside of triangles. And also working about like side lengths as well, triangles as well. But I'd like for you to turn to page 129. We're going to be skipping quite a bit and just kind of focusing on the major important questions. But as you're looking here, it says analyzing angles and sides. What we see here is a theorem. A theorem is a rule, and you'll be hearing some more theorems in Math 8. But the triangle sum theorem, which you've seen before in like 5th grade, 6th grade, it says the sum of the measures of the interior angles of a triangle is 180 degrees. This means that the sum, when you add up all the angles of the interior angles, which means inside, it adds up to be 180 degrees. So you can see we have 3 triangles here. We're going to skip quite a few of these questions, but at least we're going to answer number 1. We're going to ignore the context or the story of this, but we'll classify each of these 3 triangles. The first one here, circuit 1, this is, I'll put C1 for circuit 1. This is a right triangle. The reason we know this is because it has a right angle right here. So normally if it has a right angle, or we just call it a right triangle. For circuit 2, this, we're going to call this a specific type of triangle because of this angle. This angle is greater than 90 degrees. If it's greater than 90 degrees, we call it an obtuse triangle. So right angle equal to 90 degrees, obtuse, well, I should say greater than 90 degrees. The last one, each one of these angles here is less than 90, and we call that acute. So this should be fairly familiar. So every angle, at least for this one, less than 90 degrees. Okay. I'm going to skip these following problems because it wants you to note certain things. We don't quite have the time since I'm not in class, so we're just going to do something here with the open space that we have at the bottom of this page. I'd like for you to draw a triangle. Let's go like this. Maybe something like this. Try to draw it straighter. Okay. What we want to note is which one is the shortest side and shortest angle, okay, or smallest angle. So let's say smallest angle here, I'm going to draw an arrow. Let's say small angle. So we have 3 angles here. We've got this one, and this one. Which one do you think opens up the least? That's narrow. The right, it isn't wide. The which one? The one that is the smallest angle is this one right here. Okay, this one doesn't open that wide. Whereas the other ones open up a little bit more than that. Now, outside of that, which one is the smallest? We'll say smallest side. So is it this side, or this side? Okay, the one that has the smallest side is right here. Okay. And then finally, from there, let's also note which one is the biggest. So which one is the, we'll say big angle. Okay, so which one, we already know which one's the smallest one, so it's in between one of these two. Which one opens up wider? The angle that opens up wider is this one. And I'll put that in red. Okay, and then finally, which one has the big side? The biggest side is right here, right? If you were to measure all three sides, right, this one would be the biggest side. Now, what I want you to understand from this, because what the book is asking you to grasp from this, is I'm going to take this figure actually. I'm going to take this figure so I can annotate it a little bit larger. I'm going to put it over here. Oh, that's a lot of stuff. Alright, give me a second. It's just a lot of things I want to get rid of. Okay. Oof. Okay, I guess that's the best we can do. Is I want you to notice the relationship between the smallest angle and the smallest side. The smallest angle was this one that was in blue, and the smallest side was the other one that was in blue. So smallest angle here, I want you to draw this line from here to here. Right, a vocabulary term is, this is what we call is opposite. So the smallest side was opposite the smallest angle. The reason we call it the opposite is because the ones that are, let me use orange, that form the angle, this side length and this side length, those are what we call as adjacent. Okay. And then the other one that we noticed, the biggest angle, which was this right here, corresponded with the biggest side, which was this right here. Okay. This was also opposite. Right? This was that longest side. So key thing here, and we're going to actually write this on the next page. So let's move on to the next one. So C, what do you notice about the location of the angle with the least measure and the location of the shortest side? Okay, we're going to put shortest side is opposite / across the smallest angle. Okay. Now D, it's the same exact thing, but it's saying describe what you notice about the location of the angle with the greatest measure and the location of the longest side. This we put the same exact thing, except the longest side is opposite or across the biggest angle. So we're going to get through a couple of problems here. So we're actually going to skip some problems. We're going to skip D, 5, A, B, and C. I'm actually just going to go to number 6. Number 6 says, list the side lengths from the shortest to the longest for each diagram. Now for 6A, we have a diagram, but it's not quite complete. The reason I say it's not complete is because we're missing one of these side lengths. We're missing this angle right here. So, right, earlier we talked about how the three angles in a triangle add up to 180. You're welcome to use a calculator, but let's do some scratch work here. I know 8, so let's do 81 plus 52. This is 3, this is 13. Okay, how can I figure out this missing angle? I know that these two angles here add up to be 133. I can subtract it from 180 to figure out what is that missing angle. Now when you subtract, right, in our ones place, you can't take away 3 from 0 and get a positive number. So we have to borrow. Typically, I'll borrow from the 8, or you can borrow from the next digits, the 18. I'll borrow from the 8 though. This 8 becomes a 7, and this 0 becomes a 10. 10 minus 3, 7. 7 minus 3, 4. And 1 minus 1 is just 0. So it's just 47. Let's put 47 here. Okay. So to list these angles from, so we had to do some work at the beginning, but not too bad. Just addition or subtraction. List the side lengths from shortest to longest. So our side lengths are M, P, and N. The smallest side was, or smallest angle is this one right here. right? 47 is the smallest of the three. So the smallest side length, it's kind of hard to see unless you like were to measure each side. But we can tell, right? It's the one that's right across. So this one, P, is going to be the smallest side in order from least to greatest. So let's go to the next one. Which one's second? In the middle, smallest. Right, 52 is smaller than 81. So let's go to the opposite for that. So that means N is the middle of the three, and 81 is the biggest. So the biggest side length, the one that's across from it, is M. Okay, let's use this understanding to help us for B. We're going to go a little bit faster though. This is 45 and 50, so if you add that, that's 95. I need to find this missing angle here, so this, I'm going to subtract it from 180. Okay, let's make this a 7. 10 minus 5 is 5. 7 minus 9 I can't figure out, but I could do 17 minus 9. That is 8. So this is 85. Alright, now we're combining this with the other triangle. We're saying that this side length here, we're calling it G. But the angles here, I do have a 50, I have a 38. I don't have this one though, so we're going to do this again. 50 plus 38 is that 88? So subtract that from 180. Or this is a 2. And this is a 9, so 92. Okay, so we've got a couple of angles here. I'm going to highlight them in blue. And we're just going to compare. We've got two triangles. So 3 and 3, so 6 total angles here. Okay. Which one is the smallest number? I think it is 38. So the side that's opposite of it is F. I'll write that. Okay. From there, the next one looks like it is, which one would it be? It is 45. Okay, so 45. So that means it'll be the one that's across from that is G. Then we have 50 right here. The one that's across from it is E. But we also have a tie here because this one's also 50. So yeah, I'll just put E and then H will go in alphabetical order. And then from here, the biggest one is 85, which will lead to D. Okay. Anyways, so we're just using these two problems here, right? Looking at which one's smallest to biggest and comparing the side lengths. All right. We're going to work a little bit faster though for the next activity. We're going to really summarize this. So we worked with the interior angles of a triangle. Now we're going to work with the exterior angle of a triangle. The exterior angle of a triangle, so 1, 2, and 3 are inside of it. The one that's exterior is this one, which is number 4. It's on the outside of the triangle. Okay, so something we need to note here is we're going to come up with another rule. Right? What rule can we come up with these problems? And we're actually going to work on a couple of these problems here. So I'm going to skip number 1. What does measure of angle, so we're going to go to number 2. What does measure of angle 1, 2, and 3 equal? We know that angle 1 plus angle 2 plus angle 3 equals 180. And then number 2b, measure of angle 3 and angle 4. Now we already talked about in transformations, right, a rotation of 180 degrees, right? Like you don't have to draw this, but if I rotate, right, this person, let's say about here, right? It would go upside down, something like that, okay? Right, it would rotate half of a circle. Now half of the circle is 180 degrees. And this angle here and this angle here form a straight line, which means that it's also equal to 180. So 1 plus 2 plus 3 is 180, but also measure of angle 3, whatever that is, plus the measure of angle 4, whatever that is also 180. All right. Now, what these both share, they have something in common. The thing that they both have in common is angle 3. Okay, so what can we say? If 1 plus 2 plus 3 is 180, and 3 plus 4 is also 180, we can make make a assumption or prediction of what can we say for the other ones. So measure of angle 1 and 2 and 4. So this, what it is, it's measure of angle 1 plus the measure of angle 2 equals the measure of angle 3. Or sorry, measure of angle 4. So we're not dealing with 180 here. We just know that these equal each other. Now how can I prove that? Let's do this. Like if you were to take this angle here, shade it, and this angle here, shade it, this would equal, let me erase this. The amount that you shaded it would equal angle 4. Okay, there's a name for that. But let's go to the next page to discover that. Okay, so these are called remote angles. So remote angles are non-adjacent. Adjacent means next to, so these are angles that are not next to each other. So this angle plus this angle, I'll put a plus, equals this angle. Okay. I'll put that here again. So angle 1 plus angle 2 is equal to angle 4. All right. So this is remote interior angles of a triangle are two angles that are non-adjacent to the specified exterior angle. And it says it right here. Right, angle 4 is equal to angle 1 plus angle 2. All right, and also the theorem's written here. The measure of the exterior angle, so the one that's outside, this was 4, of a triangle is equal to the sum, where sum means plus, of the measures of the two remote interior angles. That was 1 plus 2. They're the ones that are not next to it. So we're going to finish up a couple problems on page 133. As you can see here for number 6a, right, this angle here plus this angle here, and we're trying to figure out what x is equal to here. We know that these two things should be equal to the one that's on the outside. So we're going to put some scratch work. 21 plus 132 is equal to, or we want to find what is that variable, the unknown angle measure, which is x. You can add this up, you can do some scratch work off to the side, but this would be 153 degrees. That's what x is. Okay, so we're kind of bringing back your understanding of solving equations as well from other grades. Okay, let's go to B. It's saying this angle plus this angle is equal to this angle. Okay, so let's write the first two interior ones. So that is 16 plus the other one we don't know, it's x, is equal to 143. So when you look at this, you have to think to yourself, right, 16 plus what is 143? So for this, I'd have to subtract the 16 from here to figure it out. We'd have to borrow. So this will become 3, sorry, this will become 13. 13 minus 6 is 7. And 3 minus 1 is 2. This would become just the 1 comes down. So this would be x is equal to 1 27 degrees. Okay. These other ones get a little bit more complex, but I'm going to go over one problem, and I'll leave the rest for you. I'm going to go over number 7C. So we have this angle is equal to this remote angle. So in this case, we have multiple variables. We have 2x plus 3x is equal to 120. All right. 2x plus 3x. That is equal to 5x. And this is equal to 120. Now this is saying when we have 5x, this means 5 times something. So 5 times something is equal to 120. If you're not sure what that is, what we can do is we can go in the reverse order. We can use the opposite of times. We can use the opposite of multiplication. The opposite of multiplying is dividing. So what you can do is you can actually divide 120 by 5 to figure out what your answer is. You can also put this into a calculator, but let's do this freehand. 5 cannot go into 1, but it can go into 12 2 times. All right, 5 times 2 is 10. 12 minus 10 is 2. We'll bring down this next place value. And 5 can go into 20 4 times, which is exactly 20. No remainder. So we can say that x is 24 degrees. You can plug that into each one of these to figure out what their specific angles are. But we're going to leave it there. We're not going to do talk the talk. On the assignment, I'd like for you to put your name, date, and period. Do numbers 1, everything, A, B, C, and D. And on the back side, I'd like for you to do number 2, number 2A. And I'd like for you to do number 3A. Okay, so that's a total of 5 problems. Okay, all right, thank you.